Somebody knows the first step. What's the first step? Leslie? Yeah, we got to start with the segment. This is one of the rays. All right, then what do? We get a compass. Let's start with B. We're going to put our compass where? On the vertex of B, correct? We're going to open up our compass, and we're going to do what? Make an arc. Now, we're going to keep this opening. We're not going to adjust it, and we're going to move over to angle A, and we're going to put our compass point on the vertex there, and we're going to do a what? A what? Another arc. Then we're going to move our compass point to our end point here and do what? Make a very large arc. Any questions so far? That's the easy part on the computer. The next part for me is hard. All right, so now what we have to do is we have to come up here and we have to measure. You have to measure this angle. So you're going to put your compass point. Maybe I should do it. I'm going to put my compass point here. And I'm going to close my compass so my pencil point is right there. So what I'm doing is I'm measuring the opening. Got it measured? Okay. Could you see what this compass point is? It's going to come right down here, and you're going to put the compass point there. And then you're going to draw an arc. Remember how a segment, we kept adding onto the segment? We're going to keep adding onto this arc to add angles. So now we're going to take, everybody with me? So now we're going to take our compass point up to A, and we're going to adjust our compass again. So my pencil point is on, my compass point is here, my pencil point is there. If I'm adding, where am I going to put this compass point? On the last arc I did. If I was, and I'm going to do an arc this way. If I wanted to subtract, I ran out of pencil. There we go. So if I wanted to subtract, I would be doing it this way and removing that angle. So now, what happened to that arc? Did it really move? Okay. All right, so now my sum is going to be from here through that point of intersection. That's angle A plus B. What's next? Do you want to do A minus B? Or B minus A? What's another problem? Number 5? So 4 A's minus a B. Okay. So I'm going to delete this. I'm going to delete this. We start the same way. Any questions there? So now what we're going to do is we're going to measure A because that's where we need to be first. We're going to measure A.
All right. Number 11 on your worksheet, number 11 on the worksheet must be negative. I got a negative 50. Here's that problem on your construction angles. Okay, so you got that. You did a nice job. I wrote 4 problems. So, number 11, you should have negative 50 for F. So what questions do you have? Maria, do you have questions? No. Okay, Trevor. Okay. Yes. Okay.
Mr. Bride, do you like my drawing?
Yeah, what is your
Nice.
I'm asking questions on homework. Yeah, Elder.
32 on the book.
32 on the book. Who's got a book? Anybody?
Yeah,
How many months?
Homework pass.
Number 32 says. All right, 32 was a literature problem. Am I right, Albert?
Oh, I couldn't do it because I
Oh, yeah, the round table.
You had what?
I didn't have a road
Oh.
Actually, I probably could have done it, but I didn't.
Okay, this was King Arthur and his knights around the round table. So that looks like they gave you a picture of a round table. All right, how many seats were there? Did anybody count them? 24. So if there are 24 seats and there's 360 degrees in the circle, how do you find the sector of 1? Divide 360 by 24, what is that? 15? So if they want 2, how many is 2? 30. If they want 3, how many is 3?
45.
Okay. Any other questions?
I measured it.
Okay.
Two sections of this line.
So that's close. Okay. 18 is a little bit off. For one sector, was that for one sector or for 2? Yeah.
So yeah, it will.
All right. Any other questions? Yes. No, we knew the worksheet. That was Thursday.
And,
Did I do construction of angles? I didn't do angle construction? I didn't do angle addition? Okay. So how far, I know I'm recording, how far did I get on angle addition? Did I teach you how to add angles?
with the
Yes, with the compass. And I told you not to do the worksheet?
I don't remember.
Did I teach you how to subtract angles?
I do it all.
Alright. So any questions on how to do the constructions, because the worksheet is going to have to be assigned. Yes. Yes. If you did, these are, we're going to skip this next page, it looks like it's correct.
You missed. She just tried to show Kobe.
She went Kobe.
No, but she missed. She's making me cry.
That's right, and I will make Wendy come after school too if she does that again. All right, so last call. Any questions on adding, constructing the sum or difference of angles? All right, if you get stuck, the 1-4 note B online will explain how to do that.
So did I?
So if I told you not to do that worksheet, now you have to do that construct angles
Did I do the work?
and, yeah, you did it all. Construct angles, what is it?
I don't know.
Angle addition?
Yeah, I don't even.
How do you do it?
I did the worksheet.
It's constructing
Constructing angles and angle addition with
Okay.
algebra.
So I'm going to need, right, I need this separate from this. Now you're going to be doing 2 word maps in addition to A9,
Whoa.
and we'll talk about that.
You've done them before.
I don't like word maps.
I don't care whether you like them or not.
What's a word?
You'll see.
So is when you text us what we have to do? No, I just texted you, remember the word maps because they're not part of A9.
So
on this
A9.
thing. A9, the 2 word maps, and the worksheet that I told you not to do yet. Yes. Yes, you do. All right.
Go, go. Go, go. It turned off loudly before you. Yeah.
Next one, Samantha.
What's up, Lizzie?
This is section 1.5.
So what do we really find that we're
On these notes. Watch.
Wait, is it this one? Hold up, hold up.
1.5 notes, look. Complementary angles. There's the word map for complementary angles. There's the word map for supplementary angles. We will get there, I'm not there yet.
Are we gonna go over the word map and you're gonna fill
You're
out
going, no, I'm not.
Right, what's up?
Over you're explaining.
I don't even know what word map is.
Adjacent angles, we're gonna start here.
Hold it up and get that out. What page is that
This
on?
is section 1.5.
I'm gonna write it down right here.
All right, adjacent angles. I'm not going to ask you to memorize this word, but I'm going to ask you to recognize it. There are two, no more, no less. They're called planar, meaning they're in the same plane, and there's three characteristics you need to know. They share a side. Common side means they share a side. If you recall, if I have an angle, the side of it, this is angle ABC, the side is a ray. Ray BC, ray BA. So they have to share a side. They have to share a vertex. They have a common vertex. If you recall, in this case, the vertex is at B. And then they have to have no interior points in common. So we're going to look at, we're going to talk about these three. Angle A, B, B, and then angle D, B, C. So if I look at this angle, I'm going to trace in yellow angle A, B, D. Any questions?
Hold up. I got this.
So now I'm going to trace angle B, B, C, but I'm using a different color. We use blue. So angle D, B, C. Now, why is that green and not blue or yellow?
Because it's mixed.
In other words, the yellow and the blue must have been together. Alright. So what this means is, this means that this is the what? Common side. So do they share a common side? Yes. Do they share a common vertex? Yes. Now, what does it mean to have no interior points in common? So if I trace the interior of this angle, and I trace the interior of this angle over here, did blue meet pink?
No.
That means they have no interior points in common, which means angle ABD and angle DBC are adjacent. Alright, so over here we're going to look at two different angles. Over here we're going to look at angle EFH and angle EF. Then listen to the notes again. Go online. So we've got E, F, H. You see the sides? So now we're going to trace E, F, G. Which side do they have in common this time? The HF? HF is just yellow. Wait a minute, hold on. I don't have this sheet.
Me?
Thank you.
No problem.
Which one is in common? I don't know. What do they have in common? EF, because it's green. This is the common side. So did they meet this first criteria, common side?
Yes.
Do they have a common vertex?
Yes.
Yes. Now, watch the interior points. The interior points for EFH. This is EFH. Okay? Now we're going to do EFG. EFG includes this and this.
Oh, got some really good.
Do they have anything in common?
Yeah, except.
Interior
They don't have, they have,
in common. They do. Did it fail this?
yes.
Yes. So are these two angles, the big one and the little one, adjacent? No. That's, I don't think so. They're going to ask you to identify these angles.
Yeah, I do that.
You can do that, but make sure it is done on your real paper.
How did they not have interior?
They do. They have all of these interior points in common, which means it is failed. So these angles, these two angles are not adjacent. Now, if I were talking about this angle, if I were talking about this angle right here, that angle right there, they would be adjacent. I talked about the big one and this little one. So they're not adjacent.
So if it was equal HFG, would it be adjacent?
HFG is adjacent to EFH, yes.
So why is that not?
Because I'm not talking about HFG, I'm talking about EFG. I'm talking about the big one.
They're all not, it's not all together basically.
So
You
you're
see,
saying,
this angle's inside the big angle, that's not adjacent.
Oh, okay.
so if there,
If we look at this one down here, these are not adjacent, where do they fail?
I thought
Okay.
At the vertex,
yeah.
okay? This angle is J, that vertex is K, so it fails because of the vertex. Alright, so now we're going to talk about vertical angles and linear pair angles, and these angles are angles we're going to see all year long. What word do you see in linear? Line. Okay. Vertical angles are two angles whose sides form opposite rays. Another way we could think of this maybe as whose sides form lines. So, if you look at this, you agree this is a line,
Yes.
and that this is also a line. Okay. So, what are vertical? Vertical are the ones that are kind of opposite. 2 and 4 are vertical. Angle 2 and angle 4. Raise your hand if you have any questions. There is another pair of verticals, and those would be angle 1 and angle 3, because they're opposite. But again, they have to form with two lines.
So 1 and 3 are not vertical.
1 and 3 are vertical, 2 and 4 are vertical. 1 and 2 are not vertical.
2 and 1 are not vertical.
2 and 1 are not, 2 and 3 are not, 3 and 4 are not, because they're not opposite. Alright. So let's talk about a pair of linear pair angles. Okay, linear pair again are a pair, that means there's two. They are adjacent, we just talked about adjacent. Now we're going to talk about non-common. The non-common sides form opposite rays, or we could say the non-common sides form a line. If I were to trace angle 2, and I were to trace angle 3, maybe I'll do it. You see the common side.
2 and 3.
This is a common side, correct? So when we're talking about the non-common side, we're not talking about this one, we're talking about those. And those form a line.
Yes.
Hence, they're called linear. So angle 2 and angle 3 are a linear pair. There are more linear pairs up there. Angle 2 and 3, angle 1 and 4,
Also the ones that ain't other.
angle 1 and angle 2,
Angle 4 and 3.
angle 4 and angle 3. Excellent.
Wait, what are the? Oh, that's wait. I don't.
Those are angles.
What is that? What is that?
This is, okay, when we talk about a pair of adjacent angles, they're non-common side, that's the common side, because there's the overlap. So we're talking about this blue and that pink form a what?
The line.
If you look at 3, and if you look at 4, There's the line. There's the common
Oh, but
side.
if you look at 2 and 4, then they're not.
No, because
all
2 is going to be
right
bigger.
there are separate lines on it. But angles you wrote down are what's showing up here.
Are the linear pair angles.
Oh,
Okay, every one of these is a linear pair.
so if they have like a share line,
If they share a line, they're linear pairs. Now, 2 and 4 don't share a line. Okay? Because 4 is here and 2 is there. But they're formed by 2 lines. You have to have 2 lines that cross to get your vertical angles.
Wait,
So-
so both of those problems are asking for 2 different things?
Yes.
Okay, I get it.
So in this picture, notice I did not extend this. There's one pair of vertical angles. Because they're going to do that on the EOC, and they're going to do that too. There's only one pair of vertical.
Name one pair of
Excellent.
So, vertical.
There one.
So are there 2 lines that intersect?
Yes. Yes.
Do those 2 lines intersect?
Yes.
So what angles are formed by those lines that are kind of opposite?
1 and 5.
1 and 5 are, we're looking for vertical.
No,
Three and one.
it's 1 and 3 and 2 and 4.
Hold on. 3 is not.
2 and 1
It's 2
and
and
4.
5. Because the lines have to form the sides. What's wrong with 1 and 4? This line stopped. 1 and 3, no.
Why is that enough?
Because this didn't extend.
So that type of extra.
It has to be in an X. Okay, the angles have to be in an X.
Oh, I didn't read the problem. I just said
Okay. So now, there are 2 linear pairs. What are my linear pairs?
3 and 1.
3 and 1, you do the 3 and 1 form on outside
it's
side form
actually
line.
3 and 5.
Now 3 is here,
And 5 is.
and 5 is there. They don't even share a side in common. They're not adjacent.
3 and 4.
3 and 4. So you're telling me that this side and this side form a line.
No, 3
2 and 4.
2 and 4.
Okay.
3 and 5.
3 and 1, yeah.
3 and 5.
One and
Hold on.
It's actually right.
Now remember, they have to share. They have to be next to each other. So what are we looking at next? What are we looking at next?
3 and 5.
Okay, 3 and 5. Are 3 and 5 adjacent?
They make
No.
Are 3 and 5 adjacent?
No.
No.
Okay, what does adjacent mean? They have to share a side. There's 5.
Oh,
and
no,
here's
they
3.
don't. They share.
If they share a side, they share a vertex, but do they share a side?
No.
To be linear, you must be adjacent.
So that's
Oh.
Okay, so now let's look at
2
4
and
5.
1.
Oh, yeah, 3 and 1.
You're
I
younger.
lost this.
What's happening? 1 and 2 now.
Hold on.
2 and 1 is right. I know, right?
Alright, quiet. Now, I heard 3 and 4. 3 and 4 are adjacent. But do their outside sides form a line?
No.
No.
It's 2 and 4. I just
2
said
and
that.
4.
2 and 1.
Okay. Are 2 and 4 adjacent?
No. No.
They're not adjacent. They don't share a side.
2 and 1.
It's 1 and 2.
Okay, I heard 1 and I heard 5. Now, are they adjacent? Yes.
They
Do
form a
the
line.
outside sides form a line?
Yes.
Yes. Angle 1 and angle 5 are linear.
What about 1 and 2?
Brian said, I just erased my 1 and 2. Angle 1 and angle 5. Alright, so now let's look at 1 and 2. Here is 2,
Is that not right?
and here is 1. Do they share a side? Are they adjacent? Yes. Is the outside of them a line? Yes. So angle 1 and angle 2 are linear pairs.
So here.
1 and 2 are linear also. 1 and 3?
You
No.
held on to 3 and
1 and
5.
2 and
You held on to 3 and 5.
I did, but I also said 3 those.
Any questions?
I'm not good.
Alright, so we're going to now talk about complementary angles, which you have learned before. Complementary angles are two angles that do not have to be adjacent that add to 90. So when I'm asking you about what kind of mathematical relationship do they have, what am I referring to? They sum to 90, they add to 90. Alright, you see this little box here. That little box indicates 90 degrees. And if we look at angle GHJ and angle JHI, by angle addition, don't they equal the big angle?
Yeah.
So that is 90. So if I tell you this is 60, then this angle must be what? Sorry, they answered for you. Now again, if I tell you these two angles are complementary, they do not have to be adjacent. And I tell you that this is 50 over, what is this one? Over what is this? 40. Excellent. Alright, so let's make it more fun. What if I don't tell you this is 60? What if I tell you this is x plus 5? And I tell you that this is 8 plus 4.
You can do X plus
Oh, wait a
9.
minute, Madison is in economics.
X plus 5 plus 8 plus 4.
8x. 8x plus 4. Excellent. Alright, we're catching on. This is getting clear. So we would have 9x plus 9 equals 90. You would subtract 9 and get 81. You divide by 9, and what is x equal? Well, then what is this angle? It's 14 degrees. That's what we do. All right. Any questions about complementary? So what I've done is you have to do the constructing angles and angle addition worksheet if you've not already done it. You have to do A9, which is a relatively short assignment, I believe, and then you've got a complementary word map, and there it is, complementary angles. So if you need to see what I'm asking you in these 4 quadrants, go online and look at the notes. Oh, now the next slide talks about supplementary angles. Supplementary angles, again, are two angles, and the relationship is going to be add, but they don't add to 90, they add to 180. So, you have complementary that sum to 90. You have supplementary that sums to 180. Alright, C, S. C comes before S in the alphabet, 90 comes before 180 in the number line. That will help you remember. Ethan.
Can it only be 2 angles?
Yes. Alright. Again, they do not have to be adjacent. Right.
So the ones in the island
And supplementary. Because you already did that. That's what I'm going to do. Alright, so what if I told you this is 60? What is this going to be? 120. What if instead of 60 I told you this was 2x plus 1, and this is 7x plus 8, Trevor? What would then the supplementary what equation this be like?
2x plus 4 plus 7x plus 8 equals 180.
Okay.
Supplementary
Supplementary is 180. 7x plus 8 equals 180. Alright, so you see, it's already clicking that you take the words, the definitions that we have in geometry, and it's those words, those definitions that tell you how to write your equation, or how to do your arithmetic. So this is going to be 9x plus 9 equals 180. Let's try next step, Eric. How do I solve? Okay, how do I enter this addition? I'm going to subtract 9 from both sides, so you're going to have 9x equals 171. Eric, what are you going to do next? and you're gonna have x is equal to, I think, 19. So we just talked about supplementary angles and that they add to 180. So if you're told that these two angles are supplementary, then by definition, these two should do what? Add to 180. Yes. Two angles, they're always two angles. And they always add. But if I ask you for angle PQR, then you go back. Alright. So now, this is the supplementary angle word math that I've asked you to do.
And this is all in A5.
Okay, so this is all in A5, this is all in A9.
1.5.
Okay, angle bisector, let's talk about, did we already talk about angle bisector?
No.
Okay, well, we talked about segment bisectors. What does a segment bisector do?
2 parts or 4.
That's segment addition. Okay, segment bisector, what does a segment bisector do? Two equal segments, right. So what is an angle bisector going to do?
2 equal angles.
Excellent, 2 equal angles. So it's going to be an array that contains the vertex and divides the angle into 2 congruent angles. So when I see angle bisector, what do I want you to think? 2 equal angles. How do we mark an angle bisector?
With the R.
With the arcs. So if RO is an angle bisector, then I know WOR is congruent to RO. So what if I tell you this is 2x minus 5, and this is 3x minus 20? Wendy?
2x minus 5 equals 3x minus 20.
Okay. Why?
Because the 2 equal angles.
Because they're 2 equal angles, alright? So now let's change this a bit. What if I didn't tell you this? What if instead, what if instead I tell you that this is 5x minus 30?
Wow! 2x minus 5 plus 2x minus 5 equal 5x minus 5.
Okay, and remember what we're doing said.
I would have said, like, 2x minus 5 in parentheses, equal to 3 and 2.
Okay, so you would have doubled it. It's the same thing. I don't care how you do it, as long as you do one of these two. If this is 2x minus 5, it makes sense because they're congruent, but that has to be 2x minus 5. So by angle addition, this plus this equals this. We've done this with segments, we're just repeating it with angles, so there is nothing new. So I'm going to add to, well, we'll do angle bisector tomorrow. I'm not finished. Alright. Ray CD bisects angle ACT. Can you draw a picture of that? Don't pack up, we still have 5 minutes.
Oh my gosh.
A, C, T, and we've got CD bisects. Now how do we, that's draw, label, and now we're going to mark. So if I tell you that ACT, the whole thing is 132, what is DCT? You did 132 what? Divided by 2, which is going to be 66 degrees. What if I tell you ACT is 11x minus 18, and I tell you DCT is 2x plus 9? Neil, what am I going to do?
2x plus 9 plus 2x plus 9
Excellent. Okay, what if I tell you that TCD, changing it, is 13x plus 24? And I tell you DCA is 10x plus 63. Now what are we going to do? Okay. Caitlin?
10x plus 63.
Okay. There's no longer a point. Oh, okay. So 10x plus 63 is equal to 13x plus 24. Alright. So I think we're finished. today, yes.
Wait, let's record that so
Yes, it's gonna be on YouTube. I want you to please do problem 1 in your notes. Get busy now. How much can be traded on the